Hello everyone and welcome to our channel Mootechie. We're thrilled to have you here, whether you're a seasoned engineer, a dedicated student, or just someone with a passion for how things are made. Today we're diving into the foundational world of workshop practice, with a comprehensive guide to bench work tools. So let's get started and explore the incredible instruments that bring precision to life. Now let's begin with the very basics of measurement. Linear measurement is our foundation. It's crucial to understand these units. Let's go through them clearly. We have 1 mil is equal to 0.001 inch or 0.0254 millimeter. 1 inch equals 1000 mils or 2.54 centimeters. 12 inches make 1 foot, which is 0.3048 meter. 3 feet are in 1 yard, that's 0.9144 meter. 5.5 yards or 16.5 feet is 1 rod, also known as a pole or perch, which is 5.029 meters. And many more for reference. Moving forward, let's understand the context for all these tools. Bench work holds an essential position in all engineering works. Even in highly mechanized workshops with automatic machines, bench work maintains its own vital importance. You see, while jobs can be finished to a fairly good degree of accuracy through machining, they often require final hand operations to achieve the desired perfect accuracy. Now, what's the first thing you need to do any work on a bench? Hold your workpiece securely. This is where fitters' vices come in. Vices are the most suitable and widely used tools for gripping different jobs in position during various operations in a fitting shop. And there are a number of different types like the parallel jaw vise, machine vise, hand vise, and pipe vise. Let's examine the most common one, the bench vise or parallel jaw vise. The diagram shows its main parts. We have the movable jaw, the jaw piece, the fixed jaw, the body, the handle, and the nut. The width of the jaws for common work varies from 80 to 140 millimeters, with a maximum opening of 95 to 180 millimeters. Next up is the pipe vise. This is a specialized plumbing tool used to hold a pipe or tubing securely so it can be cut or threaded. It's also incredibly useful for pipe welding. In a manufacturing environment, a pipe vise is a critical piece of apparatus for assembling pipeline components. For smaller items, we have the hand vise. The image shows a small clamp-like tool. The hand vise is used for gripping tiny objects like screws, drills, rivets, and other similar materials which are too small to be held conveniently in the larger bench vise. Now, onto a tool for testing precision, the surface plate. Imagine a heavy cast iron plate with a square or rectangular top that has been perfectly planed true and square with its adjacent machined faces. Its specific use is in testing the trueness of a finished surface, checking a tri-square, and providing a solid bearing surface for V-blocks and angle plates during scribing work. And speaking of supports, let's look at the V-block. The diagram depicts a metal block with a V-shaped groove and a U-shaped clamp on top. A round job or workpiece is shown sitting in the V. A V-block serves as a very useful support for the work during marking. It usually works with a U-clamp. The round bar is placed longitudinally in the block and the screw in the clamp is tightened. It's specifically used for holding round bars during marking and center drilling their end faces, and it's also perfect for holding round bars in drilling operations. Now, how do we mark on these setups? With a simple scribing mark tool. This image shows a device with a heavy base, a vertical spindle, and a scriber or marker that can be adjusted in height. It is the principal marking tool in a fitting shop. It consists of a cast iron sliding base fitted with a vertical steel rod. We use it for locating centers of round rods held in a V-block, describing straight lines on work held firmly in position, and drawing lines parallel to a true surface. For ensuring perfect angles, we use the tri-square. The illustration shows the classic L shape of a tri-square, with a thin blade fitted into a thicker stock, forming a perfect 90-degree angle. It's a very common tool used for scribing straight lines at right angles to a true surface, or testing the trueness of mutually normal surfaces. But what about angles that aren't 90 degrees? That's where the bevel gauge comes in. Whenever angles other than right angles need to be tested, set, or marked, we use the sliding bevel square or bevel gauge. The image shows a tool with a stock and a slotted blade that can be adjusted to any angle and locked with a screw. It's wonderfully versatile. Now let's talk about one of the fitter's most fundamental tools, files. Files of different types are the principal hand tools used by a fitter. All files have two main parts, a toothed blade and a pointed tang that fits into a handle. The teeth can be single cut or double cut. Single cut teeth are parallel and at a 60 degrees angle to the center line. Double cut files have two sets of teeth, the overcut at 60 degrees and the uppercut at 75 degrees to 80 degrees. Files are also classified by coarseness. Let's go through the grades. 1. Rough, with 10 to 4.5 cuts per 10 mm length. 2. Bastard, with 18 to 6 cuts per 10 mm length. 3. Second cut, with 21 to 11 cuts per 10 mm length. 4. Smooth, with 30 to 15 cuts per 10 mm length. 5. Dead smooth, with 35 to 28 cuts per 10 mm length. 6. And super smooth, with 63 to 40 cuts per 10 mm length. For an even finer finish, we have scrapers. Scraping is a very important hand operation used for obtaining a fine surface finish, particularly for removing convex spots from machined surfaces. The tools for this are scrapers. They vary in shape and size and are often made from old files that are heated and bent to the desired shape and fitted with a wooden handle. Now for a more forceful tool, chisels. The diagram shows 4 common types: the flat chisel, the crosscut chisel, the half-round chisel, and the diamond point chisel. Every chisel has a head, a body, and a point. There are many varieties used for chipping work. The included angle at the cutting edge, known as the point angle, is critical. It varies between 40 and 70 degrees depending on the material. For brass and copper, it's 40 degrees. For wrought iron, 50 degrees. For cast iron and general cutting work, 60 degrees. And for cast steel, 70 degrees. Let's see what each chisel does. 1. A flat chisel is a general-purpose tool used for cutting work, chipping large surfaces, and cutting metal sheets and rods. Since it cuts cold metal, it's often called a cold chisel. 2. A round nose chisel is used for drawing eccentric holes back to the correct center and for cutting oil grooves in bearings. 3. A crosscut chisel is narrow and used for cutting deep grooves, parallel grooves on large surfaces, and keyways. 4. A diamond point chisel is a special purpose tool for chipping rough plates, cutting cast iron pipes, cutting V-grooves, and cleaning angles. Before we continue, here's a quick aside on unit conversion for area, as it's often needed in workshop planning. We have 1 square meter equals 10,000 square centimeters. 1 square meter also equals about 10.89 square feet. 1 cent is 40 square meters, which is about 435.6 square feet. 1 acre is 100 cents. 1 hectare is 2.5 acres. And 100 hours equal 1 hectare. Now, back to striking tools. Let's talk about hammers. The hammer is one of the most widely used fitters' tools for striking chisels and punches. The illustration shows 3 common types: the ball peen, the cross peen, and the straight peen. The ball peen hammer is the most common. Its peen is ball-shaped, and it's used for riveting and chipping. Its weight varies from 0.11 to 0.91 kilograms. The cross peen hammer has a wedge-shaped peen at right angles to the handle, used for bending and hammering in corners. The straight peen hammer has a peen in line with the handle, used for peening or stretching metal. For cutting, we have the hacksaw. The image shows 2 types, a solid frame and an adjustable frame hacksaw. Both consist of a frame, a blade, a handle, and a tightening screw and nut. Hacksaw blades are made of high carbon or low alloy steel. Common blades are 0.7 mm thick, 12.7 mm wide, and 20 to 30 cm long. They come in coarse, 5 to 7 teeth per centimeter, and fine, 8 to 12 teeth per centimeter groups. For making permanent marks, we use a punch. A punch is used for marking and locating centers. The image shows 2 kinds: the prick punch with a tapered point angle of 40 degrees and the center punch with a point angle of 60 or 90 degrees. Now let's explore measuring and marking tools, starting with calipers. Calipers are used for measuring and transferring inside or outside dimensions. We have outside calipers for external measurements and inside calipers for internal measurements. The diagrams show their curved legs, which are designed to gently grasp the workpiece. A very handy tool is the hermaphrodite caliper, also called an odd leg caliper. The figure shows one leg is pointed like a divider and the other is bent. It's incredibly useful for scribing lines parallel to the edge of a workpiece and for finding the center of a cylindrical bar. Similarly, the divider is a classic tool used primarily for marking circles and arcs. And we can't forget the screwdriver. It's a simple but vital hand tool for rotating screws, consisting of a handle and a shaped steel blade. To make holes, we use drills. Drilling is an important operation for producing holes, and there are many forms of drills. The most common is the twist drill. The diagram details its parts. It has a shank that is gripped in the chuck and a body that does the cutting. It can have a straight shank or a taper shank. The main advantages are that the spiral flutes automatically drive out chips, the cutting edges last a long time, you can use heavier feeds and speeds, and they require less power. For creating threads, we use taps. A tap is used for cutting internal threads in holes. The image describes a tap as a toothed body with flutes, a round shank and a square end for gripping with a handle. The flutes help remove chips just like in a twist drill. And for external threads, we use dies and stocks. The image shows a die held in a die stock. Dies are used to cut threads on a round bar like a bolt. It's a block of hardened steel with a threaded hole and flutes that form cutting edges. The stock holds the die and allows for adjustment. For finishing and sharpening, we have grinding. A grinding machine or grinder uses an abrasive wheel as a cutting tool. Each grain of abrasive on the wheel's surface cuts a small chip from the workpiece via shear deformation, allowing for very precise and fine finishing. Finally, let's summarize the key bench work processes in a table. Process, description, marking. Unless the piece has been properly and accurately marked, other operations will be of no help. Chipping, removing excess metal with cold chisels. Sawing, cutting metal pieces to size and shape, usually prior to other operations. Filing, files usually cut on the forward stroke, and pressure should only be applied during that stroke. Draw filing, a special method using a fine flat file for a final high-quality surface finish. Threading, using taps and dies to create threads. Grinding, using an abrasive wheel for fine finishing and machining. And to visualize filing, we see two methods, cross-filing and draw filing. Cross-filing is the typical back and forth motion, while draw filing involves pulling the file sideways across the workpiece for a very smooth finish. And that brings us to the end of our tour through the essential bench work tools. We hope this has been an enlightening and engaging journey into the heart of hands-on engineering. Remember, mastery of these tools is the first step toward creating anything with precision and skill. Thank you for watching. See you in the next class.